Okay, let's get this show on the road and start talking about how this class is going to go. So here's how it's going to work. So the first person in the class who can get this bell for me in 5 minutes will get an A. Everyone else fails. So you guys can all go back to, I'm kidding, totally kidding. Now I feel like I've gone too far. But I had to commit. I ordered this from Amazon, and like I had to do it now because like I spent money. I literally spent money on this. Good morning, everyone. Hope you are all okay. Let me get rid of this thing here. Welcome. Trying to make sure everyone's awake, including myself. I am not a morning person, and I'm definitely not a do math in the morning person. So just make sure everyone's here. And if I can embarrass myself like that, hopefully everyone here can turn on their camera so it feels more personal. I feel like I'm meeting you guys. Hello, nice to meet you. Nice to see you guys. I don't know how many of you got that. I might be too old and that just went over people's head. I don't know. But hopefully you're all doing fine. This is applied calculus, so hopefully that's what you think you're in. So it's Math 1203. This is at Lincoln Center. And yeah, pretty much it. So what we're going to do today, first order of business, is just talk about how the class is going to be run, make sure that everyone knows like how things are going to work, including myself, because it's a little bit of a, still a little bit of a learning curve. So it all begins there. So I posted a link in the chat to our class webpage, and I'll talk about that in a little bit. But essentially, maybe I should share that with you. Hopefully you're seeing this, so apologies for all the tabs, but lots of stuff going on. So if you go to jhevon.org/teaching, that is my teaching website, which I'll probably be moving things, but we'll talk about that later. So right now, you guys are the only ones who are hyperlinked under Spring 2021. So if you go into that, that is actually the link that I just pasted in the chat. So if you click on the link I posted in the chat, it should take you right to this page. So this is going to be your hub. That's the plan. I will be recording these lectures and posting them. I will post them here. Here you'll see the syllabus, which is what we're going to talk about. So you can click there and you can get that. Nice thing about that is, so this loads. A lot of the links here are hyperlinked. So if you have the electronic version of the syllabus, you'll be able to click on links and go to places. Should be a little bit better. We're going to have online homework. The information is here. We'll talk about that. How you're going to see your grades, you can go here. Ask questions. I'm thinking of creating a forum, but that's a part of what's going on. That's going to be kind of shaky. I'll talk about it pretty soon. And we're going to take quizzes and tests. You can go here through this link. So basically what's going on is each of these links here brings you to a different platform. And I know it's kind of, it can be sort of a platform overload for a lot of people. So I thought, let me try to use the class website as a hub. If you go to a class website, you can go anywhere else. And if you like save your passwords to all the platforms, it should be relatively painless to go from here to anywhere else that you need to get to. Here are some old quizzes with answers that I think might be useful to you guys. So these are quizzes that I gave on paper back in the day. So you can use those as extra practice. I posted the answers as well. So you can look at the blank, try it out. In fact, quiz number 1 is going to be immediately relevant because your first quiz is going to cover the topics on quiz 1 as well as some other stuff. So I'll talk about that in a little bit. But how you can, the quizzes, these are the old ones, what I gave on paper, sort of like fill in the blanks here. So probably you can just do this. Fill in the blanks, what you think the answers are. I think normally for this first quiz, so this one you see, I gave it in January, pretty much about a year ago. This first quiz, I think I gave the class 20-ish minutes. So you can try quiz one, try to do everything in 20 minutes. And then what you can do is you can check if all your answers are here. So let me not show those very quickly. Quiz one, you should be able to do right away because it has nothing to do with calculus. It's actually just me testing whether you have the prerequisites. So it's testing your pre-calculus, whether you know about arithmetic, how to solve equations, how to sketch certain common curves, that sort of thing. So those are a bunch of stuff. I also have tests and test reviews, what you would expect to be on each test. Your tests will probably be a little bit longer, maybe about an hour. Because my other applied calculus class has 50-minute sections, but you guys, we're together for an hour and 15. So I'll probably make your test a little longer. Here's a mock test for number one. You can find the solutions here. Test two, here's a mock test for that. I don't think I did the solutions there. And for the final exam, there's a mock final exam. In fact, this is the final exam that I gave in spring 2019. Your exams are going to feel a little bit different because they're not on paper, but it's the same subject matter. So going through this should still be relevant. Here's some class handouts that I'll be giving you, or I'll be mentioning that I'm using, so you can find those here. So yeah, this is the site. And as time goes on, I'll update this and populate this here. And the video plays will be there. So that's kind of where you can find everything. Let's see. Is there anything else I wanted to show you on the website? Probably not right now. Okay, so let me share my other screen. Okay, so hopefully you're seeing that okay. So what we're going to do is I'm going to go through the syllabus with you guys to make sure that we're all on the same page. You know how things are going to work, and you can ask me questions if you have any. And yeah, just as a disclaimer, on top of the disclaimer that you have here, I expect things to be a little bit shaky starting off, so I do apologize for that. And that's because when this whole thing happened, you know, that whole thing back in 2020 when all the schools went online, everyone was teaching on paper, right? So I was used to teaching on paper, but you know, we had to shuffle and get everything online. And a lot of education companies, which very thankful, very grateful for, because of the unprecedented situation, they offered their services for free. So what happened is, okay, I moved everything online. I got all these online platforms to make everything work. And it started working pretty well. In fact, I started getting very comfortable with all these platforms that I was allowed to use for free. But of course, 2020 had to end. And of course, they're businesses. They can't offer their services for free forever. So a lot of the things that I had in place, like set up, suddenly I don't have them anymore because now like I'd have to pay for them, you'd have to pay for them, and I want to kind of keep the things we have to pay for to a minimum. So I'm kind of working around getting some new platforms. And in fact, one of the platforms I used was Piazza, which was a really nice platform for engagement. It's kind of like a forum-ish thing for the class. And so I pretty much think the best alternative is going to be to build my own forum, which is why that questions part of my website is under construction. But there'll probably be a lot of things like that, a lot of under construction things. And I just want you guys to know that that's kind of what happened. I totally forgot that free lunch can't happen forever. But we'll get through it. In terms of the material, there's no such worry. We'll be doing calculus. It has been the same for like 3 centuries. So when it comes to the actual lecture material, everything is set, like you're good. But when it comes to like administering the class and making sure where do we submit homework, where does this happen, that's going to be a little iffy for the first week or so. Okay, so hopefully that's that. So I am your instructor, Jhevon. And that's my email, jsmith306@fordham.edu. Reach out to me there anytime. And I know some of you are wondering, wait, is he really the 306th J Smith at Fordham? And yes, I am. I don't know what's so special about 306, but I have that email. Office hours, Thursdays and Fridays, and by appointment. So office hours, I kind of had to just put something down. So I decided to just put down some times when I feel like I'd be most available and be able to do office hours. But if those times don't exactly work for you, you can email me and we'll set up an appointment and we'll meet at some other time. Office location would be over Zoom. So once you email me and say, hey, I want to meet you during office hours, I'll send you a Zoom link. The class website is right there. I posted that in the chat, so you can go directly there. You will also find a copy of the syllabus that I'm reading with you. The class textbook is Brief Applied Calculus. You don't have to purchase the physical textbook unless you want to. If you're just one of those people who like physical textbooks, this is what it looks like. It's the first edition, so it shouldn't be too expensive, but you don't actually need to get it. Because of our online homework, you'll have an e-version of the textbook. So if you sign up for the homework, you will have access to the textbook. Overall, you probably won't need the textbook all that much. I plan on pretty much telling you everything you need to know in the lecture. But if you want to get extra practice problems or something like that, the textbook might be useful. You look in the exercises. Okay. Let's keep moving down. So that was my little disclaimer. Just things might change here and there, but of course I'll inform you guys. And I'm never going to change anything in a way that's going to negatively affect student performance. So you never have to worry about that. Calculators, in general, they're not allowed on quizzes or tests, but of course you might find them useful in doing your homework. That's the usual GPA grading chart. You can find more information on that by going to this link here, which is hyperlinked. How your grade is going to be calculated in this class, it's going to be based on homeworks, quizzes, tests, and the final exam. So homework is going to be online. It's going to be done through WebAssign. I'll talk about that in a little bit. Quizzes will be 15%. There will be 5 quizzes given. I'll tell you when they're going to show up. They're not pop quizzes. And I'll drop one of these quizzes. The first quiz is in about a week, by the way, so just so you're aware of that. And that quiz is going to cover prerequisites as well as whatever I cover this week, which is still going to be a lot of prerequisites. So our first 2 classes, I do want to start with some prerequisite material, so we're not going to start calculus right away, but we are going to start talking about just a quick crash course in exponentials and logarithms because it's important. And it's one of those things that I feel like, in my experience, students just, they're not as sharp with those things as they should be. So I want to go over that, but I can't go over all of pre-calculus. So I'll just go over that. Tests, there'll be 2 tests. The tests aren't cumulative. I'll tell you what they cover. Roughly speaking, one is going to happen in the middle at midterms week, and the second test is going to happen towards the end of the semester. So pretty much the week before finals week, or your last class, something like that. The final exam, that one is cumulative. So it's essentially going to be like a combination of test 1 and test 2. So each test, they're going to be an hour-ish long individually, and the final exam is going to be about 2 hours long. And it's going to, the final exam covers everything, but the tests, they don't overlap unless, you know, incidentally. So yeah, and I'll tell you when to expect all this pretty soon, so don't worry about it. Usual makeup and exam policy. Quizzes, no makeup for quizzes or homework. No makeup for quizzes because I'm dropping one of the quizzes, so you can miss one. No makeup for homework. I'll tell you why later on. For tests, though, if you miss a test because of a very important extenuating circumstance, need to let me know and we'll try to set something up for a makeup. Attendance, keep attending. During the regular semester when things are in person, I normally give credit for attendance, but it's kind of weird doing that here. So I won't, but good attendance, it does correlate with better grades. So I think you guys should show up. It'll give you an opportunity to ask me questions in the moment, and just being more engaging, which we'll talk about, is going to be, it's better if you show up and participate. Work ethic, pretty much work hard, harder than you think you have to, especially if you had calculus before. Somehow, strangely, it turns out that students who've taken calculus before tend to do worse in college calculus than their counterparts who haven't. And I think a part of that is because they feel like, oh, I've taken calculus before, so I don't need to work as hard. But that's not true. If you slack off, it will come back to bite you. So a little paragraph about that. Homework, quizzes, and tests. So as I mentioned, Cengage is the publisher of our book, and they are the host of WebAssign. You can find information about how to sign up for WebAssign here. And when you do, you will need this code right here to actually sign up for the class. Okay. Right now, I believe there's only one homework up. It is due on Saturday, if memory serves. And that is, in addition to practicing the quiz 1 on the website, it's just going to help you get prepared for the first quiz. So the first homework is already up, and it's on prerequisite material. And I think I threw some exponential and logarithm stuff there. So between the homework and the old quiz on the website, you should be good to go for the first quiz. Okay, why am I not dropping any homework? So it turns out I do give you a cushion when it comes to homework. So as you see here, if you average 85% or higher on homework, I'll bump up your homework grade to 100%, right? And that's because, of course, again, technology, right? So if something goes wrong and, you know, WebAssign isn't behaving, or there's some technological issue, or you missed a due date or something like that, you're allowed to mess up 15% of the time, and we'll just let it slide. So I don't have to be too harsh with grading homeworks. Just like, make it to 85 average, you have 100% of your homework grade. So you can get that there. And because I'm giving you essentially 15% for free, I think it's fair to just not drop any homework. Try to do everything, but essentially you could miss 85% of the homework and then only get 85% of that correct and still get 100% for your homework grade. It's not a bad deal, I think. The only thing here is, of course, this isn't free. This is something that you're going to have to pay for. I'd rather not have done that. But as I explained earlier, a lot of things that used to be free are going back to paid versions in 2021. So I apologize for that. You might have other classes that also use WebAssign. So if you are in such a situation, it's best to get the WebAssign Unlimited. That way you only pay for WebAssign once, and you'll be able to access all your classes. Other than that, if that's not the case for you, I apologize for that. But what you can do is just buy the cheapest version that allows you to get the homework. There's nothing special about going the higher tier or going to Unlimited unless you're going to use WebAssign in other classes. Quizzes and tests will be on a different website called Gradescope, and we will make sure to familiarize you with that. Tests are going to be on Gradescope. For the most part, quizzes are going to be kind of like on paper, sort of short answer, fill in the blank, multiple choice, that kind of thing, something that you can just get through quickly. It'll be auto-graded, so you can get your results much quicker. When it comes to tests, though, you will be required to show your work, scan it, and upload it. That way I can give you partial credit for things that you get on tests. And as time goes on, you'll get more familiar with that. So all your quizzes are going to be on Gradescope. So by the time the test comes around, you're going to be very used to the platform, etc. As I mentioned here, the roughly when each exam is going to happen, but I'll actually give you specific information in a little bit. Just expectations. Different parts of the class, they're going to test you at different difficulties, and this is not only is it okay, but it's actually intentional, because you can't the learning journey, it has to change as you learn more and more. So when you're just learning a topic like homework, it goes easy to get you used to everything. Then by the time the quizzes come around, it gets you a little bit harder because you're expected to have done the homework. And of course, the test now is going to test that you've mastered it. So if you feel like, oh, the test was harder than the homework, yeah, that's kind of supposed to be the case. So don't complain about that. They test you at different levels, and that's normal. That's how it's supposed to be. Like it shouldn't be one difficulty level. You have to get up to speed. Prerequisites. I expect you to remember all your prerequisites, which basically means for this class, algebra and pre-calculus. Know how to sketch graphs, know how to solve all sorts of equations, know about exponentials and logarithms, know basic algebra skills, how to simplify things, how to factor things, that sort of thing. If you're very good with those skills, you should be fine. And which leads us to the following. Here are some very bad mistakes that I expect none of you should ever make. And if you show work where you make one of these mistakes, I'm actually going to give you 0 for that problem. So it's very bad. So you should actually pretty much listen up. So let's see if my hand is working here. It's very early. So just to make sure that we're all on the same page, let's actually talk about these so we know what is expected. So why am I in green? 1, do not cancel across sums. Do not do this, okay? So what does it mean to cancel across a sum? Just so that we're on the same page. So if I penalize you on a test or a quiz, can't say you didn't know because I'm telling you. Cancel across a sum is the following. You need to remember from algebra, canceling is when you have things in common and you kind of strike them out and you can get rid of them and simplify. But you should know that you can only do that across multiplication. You cannot do it across sums. So for example, if you have 2x plus 1 and you have this all over 2, a very common thing for students to do is like, I can cancel the 2's. You cannot cancel the 2's because this plus sign here, this is a sum. You cannot cancel across a sum. So this is actually incorrect. So something like this, a student would see and they would go, oh, I canceled the 2, so it's just left with x plus 1. But that is a no. It's not x plus 1, actually. You could write it as x plus a half. That would be correct. But that's not canceling across the sum. That's dividing the 2 into each part of the sum. So that's very important that you know. It's also what you can do is you can cancel across multiplication. So if instead you had this, and there's a multiplication here, because there's the 2 multiplying the x plus 1, you can cancel across multiplication. So canceling that and getting x plus 1, that's okay. Right? So it's okay to cancel across multiplication, not okay to cancel across sums. You can cancel across multiplication and division, not across pluses or minuses. Very basic mathematical fact. A lot of people forget this though, so I just want to make sure that you guys don't. Okay, let's move on. The second thing. Another very common mistake, yet it's very elementary. It's really not a mistake that you should be making. Is do not distribute powers across sums. Now, there are a couple of situations in which something like this can sneak up on you, and I'm going to talk about all of those situations. I'm pretty sure I'm going to need more space. Okay, so what does that mean? For example, let's say you had x plus 2 all squared. A lot of students will see this. It happens very often, even though it shouldn't. And they'll be like, oh, I can just square the x and square the 2. And so that is x plus 4. not x plus 4. This is incorrect. This is what's called distributing a power across a sum. So the power of 2 cannot be distributed. This is wrong. It cannot be distributed because it's a power. You can't distribute powers across sums. You can distribute powers across products again. So if I had a 2 times an x squared, then yes, it is actually okay to distribute this here and there. So that's 2 squared times x squared equals 4x squared. By the way, a lot of students will make a mistake here and write this as 2x squared, which is incorrect. The parentheses means that the 2 has to be squared as well as the x. So that's actually okay. Let's see if everyone is awake. What would that be? Someone can chime in.
Would be x plus 2, like parentheses, and then x plus 2 and another one. And
yeah, and what does it become?
Oh, x squared plus 2x plus 2x plus 4. So then x squared plus 4x plus 4.
That is correct. That's very good. However, for this class, I will expect you guys to be able to get to, at this point, I will be able to expect you to go from here to here pretty much in one step. A lot of the problems we're going to be doing will require a lot of calculations. So you are going to want the basic calculations to be very quick. One thing you can remember is that there is actually a formula for how to distribute a square. Does anyone remember? I mean, you could do the long way and figure out the formula, but off the top of your head, does anyone remember?
A squared.
You can just chime in, Anya. You don't have to raise your hands. I appreciate it, but it's not necessary. Just when I ask a question, just go. So you can unmute yourself. Yeah?
Okay, it's a squared plus ab plus b squared.
No.
A squared plus 2ab plus b squared.
There's a 2. Right. And so basically what this kind of tells you is that if I had an x plus 2 squared, this is going to be x squared plus 2 times x times 2 plus 2 squared, which gives you the x squared plus 4x plus 4, right? But oftentimes you can skip this over, right? You just know you square the first term, take the 2 times the x times 2, that's your 4x, and then you square the last term, and that is that. So you should be able to jump from the far left to the far right pretty much in one step. Not that what we did before was incorrect. However, time is going to be an issue. When we're doing calculus and you're going through word problems and you're doing all these long processes, things like expanding a square, you don't want to spend forever on that because there'll be so much else to do at the same time. So formulas like that, I expect you to remember. This also works for subtractions as well. You just keep the same middle sign. So if I had x minus 2 all squared, it'll be x squared minus 4x plus 4. If I had x minus 3 all squared, x squared minus 6x plus 9, right? With some practice, you'll get it. And it's worth practicing little things like that. So your difference of squares formula, sum and difference of cubes formula, I expect you guys to remember that. How to conjugate and rationalize things, I expect you guys to remember that. But yeah, so remember all these things, but also remember how to do them in the most efficient way possible. So pull out all your little tips and tricks from pre-calc and kind of try to get through the pre-calc stuff quicker rather than later, because when we get to stuff later on, you'll be grateful that you did that. Yeah. So here's another way in which distributing powers across sums sometimes catches students by surprise. What's that? What is that not? Can anyone guess what the mistake here is? So very commonly, what students will do is that they'll square root each term, and they'll write this as x plus 2. This is incorrect. Now, why is that incorrect? Well, it's because a radical, as you may remember from pre-calc, is actually a power, right? If I were to write the radical as a power, what would it be?
1/2.
1/2. This is the same as half power, right? So when you write this as that plus this as that, notice what happened. You actually distributed the power across the sum, right? So radicals are powers, and students often forget this. So what you can't do with a power, you definitely can't do with a radical. And radicals are actually even more restrictive than normal powers are. There are times when what's under the radical has to be positive, if the radical is an even radical, or so on and so forth. But you can't distribute radicals across sums either, because they are powers. That's actually a very common misconception. In fact, this one is a worse mistake than this one, because when a student distributes a whole number power across a sum, they might miss a term or two or a few terms. Like here, you miss the middle term. However, to actually expand a radical like this, you'll actually need an infinite number of terms. So you are wrong, and you're pretty much as wrong as you can get. You're infinitely wrong by doing this. We're not going to see in this class how to actually distribute that, expand that into an infinite number of terms. That's usually something that students do in Calc 2, and not in the applied Calc 2 version, in the regular Calc 2 version. So, but just a fun fact, it actually, to expand a radical across a sum, it requires an infinite number of terms. But you should just know that you cannot expand that. For our purposes, if you see an expression like this, the square root of x squared plus 4, then it's the square root of x squared plus 4. You can't get any simpler than that. You can't rewrite that. That's how it's going to stay. So that you should remember. So radicals are powers. Can't distribute them across sums. You can against multiplication, though. So example, if I had instead, this was 4x squared, this is, you could actually distribute the radical across that. And that's 2x. Now, let's see who's paying attention. This is actually the incorrect answer. Can anyone tell me where the error is?
It'd be positive or negative.
Right. So what would we have to do to account for that?
You could use the sign, the positive and negative before the answer.
No, that's not how we would deal with it. Anyone else?
You use absolute value sign.
Absolute value is how you deal with it. Right. Now, absolute value has a definition with a plus and minus in it, but you have to be careful. It does not give you a plus or minus to the external value. The absolute value always keeps something positive, so it's never going to be negative. It's always going to be 0 or bigger. So recall that your absolute value of x is equal to, well, it's equal to x if your x is positive. It's equal to 0 if your x is 0. And it's equal to negative x if your x is negative. But notice that this negative sign minus x is positive if x is negative, right? So you'll never actually have the minus sign there. So when you write the plus or minus, that's actually a different thing. Saying plus or minus 2x is not the same as saying 2 times the absolute value of x. They're not the same. Yeah, so yeah, so that's something you can remember. If I had told you before that for x squared, and I told you ahead of time that our x was already positive, then you can forget about the absolute values, because then you could do this. This would be 2 times the absolute value of x squared. But since the x is positive, this part of the definition takes effect, and you can actually replace the absolute value with x. So you want to be careful of that. Whenever you have an even radical of an even power, you're going to get an absolute value somewhere, because the even power is going to turn negatives into positives. So even if you plug in negative values, you'll get a positive output. You need the absolute value there. The only way you don't need the absolute values is if you know ahead of time that the variable is positive already, so the absolute value is not going to make a difference. The absolute value just returns the same term if it's positive. Anything else I want to mention here? I think that's it. Third one, pretty quick, happens very often, and especially in calculus, it is a greater risk than you would expect. Don't divide by 0. It doesn't make any sense. Never makes sense. Not in calculus. Okay. There are going to be times in this class where it would seem like we're dividing by 0, but we're not really. We're dividing by something that gets close to 0. And when we do that, there'll be special notation for it. So writing 2 over 0, meaningless. Doesn't make any sense. That's nothing. Like if you tell me the answer is 2 over 0, no, it's wrong. Or you might say 2 over 0, that's equal to infinity. No, it's not. Or that's equal to 0. No, it's not. There are some things that would be allowed that might seem strange at the moment, but we'll get to that. 2 over 0 with a little plus sign in the power, that's allowed. Or 2 over 0 with a little minus in the power, that's allowed. But to write 0 itself is not allowed. So this is allowed. But it's probably not notation you're used to, so I will explain this when we get to it. So basically, this one basically just means it's not 0, it's super close to 0, but slightly positive. So it's 0.0000000, a bunch of zeros and a 1, for example. And this one is like, it's not 0, it's close to 0, but slightly negative. So it's like minus 0.001, right? And those things will make sense. This one, in fact, would be infinity, and this one would be interpreted as minus infinity. The one above is not. The one above means that something is going on that you have to figure it out, but it cannot be the answer itself. And we'll deal with this later. But just as a warning, never divide by 0. It's always something that you should be worrying about. So whenever you think an answer is something over 0, either you made a mistake or you're not finished with the problem. There was something that you had to do to figure out more information. But to stop at the division by 0, I guess there's no answer. It's incorrect in general. So just don't think of division by 0 as meaning anything. It means nothing, regardless. A lot of students think that division by 0 means infinity or something like that. It's not true. Division by 0, completely meaningless. And so there are times, as I mentioned, where it's going to seem like we're doing some division by 0 voodoo, but it's not. And when we get to that, I'll explain. So that's kind of, especially with the topic of limits, that shows up. So before, this is not a do not really. This is a do. Okay. but it's also something that students lose a lot of points and a lot of credit for when otherwise they're doing great. These are the silly mistakes that I've seen. I know despite how class started today, I am an adult male and I've been teaching for a long time. So I've seen a lot of mistakes. And I can tell you these mistakes that I'm showing you right here, these are the guys that are mostly responsible for students failing pre-calc and calc 1 and all that stuff. So they might seem simple at the moment, but they'll sneak up on you. Sometimes when you're doing a very long problem and you're on the 10th step, it's going to slip in there. So you need to make sure that it's in the front of your mind. Never do this, never do this, never do this. So you never actually do it. There are some things that you do want to do though. So there are some things that you should do that students often don't, and that causes mistakes. So one of these things is use parentheses when appropriate. This also applies to proper notation. Okay. This is something that's often overlooked, and it's really detrimental. Pay attention to notation, how you want to express things. And I'll talk a little bit, I'll talk about that when I go through notation. Like I said, I'm going to tell you everything you need to know. So whenever I'm introducing a new topic, I'm going to show you the notation, and it's very important that you stick to that notation, as well as just notation for general math principles. You guys should know. Sorry, did something. I clicked something weird just now. Okay, I think we're okay. I clicked something by accident and it changed the view on my screen, so it was kind of all over the place. Okay. Okay, so here's the mistake. A lot of times students will not do things even though they know they should. So they wouldn't write parentheses even though they know they should, because it's like in their head. Yeah, I know it's parentheses and I know I have to distribute, but they never write it down. And what happens is when you're on those longer type problems and you're doing a lot all at once, which is going to happen in calculus, very often you're not going to remember those imaginary parentheses that you had way up there. So sometimes the students write down the line, they should use proper notation parentheses, but they don't for whatever reason. And by the time they get 5 or 6 lines deep and they have to use something that they had up here, and then they look up, they totally forget, right? Because their mind is preoccupied with other things. So they look up and they forget that they had these imaginary parentheses there, and they end up getting the problem wrong because now they write the thing down as if parentheses were not there. So do not do that. Don't get something wrong just because you're a little sloppy with the notation. It's worth it just to be pedantic with notation. It actually saves you a lot. You'd be surprised. I've seen all sorts of things happen on tests. So for example, sometimes, so we spoke about what this means, right? And how that would be interpreted. I've actually seen situations where a student just very sloppily, they wrote this, right? So they meant to write the power 2. They meant to write the 2 very small and up to the right corner, but for whatever reason they didn't. Now the screen is doing its thing again. Okay, but for whatever reason they didn't, and they wrote this 2 very sloppily. And so they do stuff, and lo and behold, what do you think they do when they go, oh, they look at this and like, okay, yeah, distributing. And technically they're correct. If this was a 2 like that, you should distribute, and that would be a 2x plus 4. And I've seen students make that mistake just because they were sloppy with how they wrote the powers. Or I've seen students who they don't write parentheses and then they forget to distribute a negative sign because they didn't do it. So don't let things like that happen to you. So even if you know better in the moment, just do better. Just take the extra half a second and write the parentheses down. It's going to save you a lot of headache. So in regards to this, I think I want to actually try a problem with you guys. Just to, again, it's very early morning. Let's get the brain greased up. Let's do this problem together. So suppose if f of x equals 2 minus x squared, find f of x plus h minus f of x over h. Does anyone know what this is called? Anyone remember what that is? So something called the difference quotient. And for sure, you've seen it before in pre-calc, maybe even in algebra class. In this class, we're going to learn why this expression is important. So in pre-calc, sometimes you are asked to calculate this expression for no reason whatsoever. And you're like, why would you ask me to even do this? And you might think that your math teacher was just messing with you, but it's actually a very important expression to be able to calculate. So I want us to calculate this. Okay, go. How do we do the first thing? So you'd start with the f of x plus h. What is f of x plus h? That's 2 minus x squared plus h, right? Is that the first part? It's not the first part. Very common mistake. Students often make that mistake. Probably to some of you, it didn't seem like, oh, yeah, that's totally right. It seemed like nothing was wrong just now. A lot was wrong. What was wrong? What does f of x plus h mean? Can anyone explain what that means? If I were to ask you, what does it mean to have f of x plus h? Do you remember? Something called a composite function. Don't be shy. How would you describe how to do f of x plus h? Are we shy, or is it that we don't know? Because it's probably better if I know which it is. It's okay to say I don't know. It's okay to be like, oh, I don't remember. I don't know.
I do not
I
remember.
remember learning it, but I'm not like confident enough to be like, I know how to do this.
Okay. So someone put in the chat, and that's pretty correct. Except I would caution you here, you do need the parentheses. So be careful with that. So Ying Hui in the chat. So basically what it means is replace every x with x plus h, but put it in parentheses because that's going to be important. So this is an example of where a student would know to do this, but they wouldn't write it down. So what f of x plus h is going to look like is I'm going to go to 2 minus x squared. And everywhere I see an x, I'm going to write an x plus h instead. Now, sometimes students write that, and that is going to be incorrect. They're going to get in trouble. You need the parentheses here. So everywhere I see x, I now replace it with an x plus h. Okay. Parentheses important. A lot of students just wouldn't write the parentheses. So here the parentheses tell you that that negative sign has to distribute across the x and the h. So it's really minus x minus h. But a lot of students, they'll know the parentheses should be there, but they don't write it. And then later on, what they do is they just write minus x plus h, and they forget that the negative sign had to distribute. And it's not that they forgot that process. It's just that their notation didn't remind them that that's what they're supposed to be doing. They thought they would remember, but later on they forgot. So the parentheses is actually very important. So that's f of x plus h minus, now I'm going to write f of x. Now f of x is what I told you, 2 minus x squared. So this is going to be 2 minus x squared and all over h. So now we're good, right? Agreed? Everyone give me a thumbs up.
Would you have to put parentheses around the f of x?
You would. So it's incorrect as that is correct. And again, that negative sign has to be distributed. A lot of students would not write those parentheses. So there are very two common mistakes that happen here. Most students who get a problem like this incorrect, get it incorrect on the very first step. They either forget to replace each x with x plus h, and they just do a thing like plus h at the end, which is not correct. Because there's a difference between f of x plus h and f of x, and then adding an h, right? Writing down f of x and then a plus h is not the same as this. They're not the same. So that's a very common mistake. And the second common mistake is not using your parentheses. So a lot of people get in trouble because they didn't use their parentheses. Do not let this be you. Okay, so that's actually what the first step is going to look like. The people who just write f of x and put the plus h and then minus f of x, normally they get 1 as the answer. 1 is always going to be the answer when you do that, because you would have f of x, you write down the plus h, then you go minus f of x all over h. These guys will always cancel, and then you're always left with h over h, and you'd always get 1. So whenever I put a problem like this on a quiz and someone writes 1 in the answer, even if they don't show their work, I know exactly what happened. I'm like, it's not, you didn't replace each x with x plus h. Okay. So that's what the first step looks like. Okay, so let's go. We're going to distribute our signs here. So let's continue. So this is 2 minus x minus h. Okay, so this here, x plus h all squared, that's x squared, h squared, 2 plus x squared. Yeah? Everyone with me? I see some of you nodding, but you shouldn't be nodding. This is incorrect. What happened? Do you see what happened?
You use the over the sums.
I distribute the power across the sum. Right? That same thing that I mentioned up here. Do not do this, right? Remember that? Like when I show you the isolated example, You might say, oh yeah, of course, okay. You might have forgotten in the beginning, but then when I said this, you're like, oh yeah, that makes sense because it's really the x plus 2 times x plus 2. Okay, I get it. However, when your brain is focused on doing something else, like computing this guy, and while you're doing that, you end up in a situation where you have a power of a sum. If you're not careful, the mistake can slip and you're not even going to notice it. Like a lot of people were nodding and they didn't even realize that I did that mistake because they were like, oh, it seems fine. No, what happened here was the square, I distribute the square to the x and the h. Not allowed. Yeah, so this is incorrect. That is the second most common mistake. So half the people who get a problem like this wrong will get it on the very first line. Of those that remain, another like 75% would make this mistake. Or maybe another half. And then another 25% would forget to distribute the signs because they forgot they didn't write the parentheses. Very common. Like the first two lines in this problem, most students who get it correct, they get it incorrect. Most students who get it incorrect within the first two lines. Because a lot is going on here. A lot of algebra is happening at the same time, and you just have to be very careful. So it's very important that you go over these rules that I mentioned earlier, one by one, and really drill it into your brain what this means and certain things that are not allowed. It should get to the point where it comes in as muscle memory. Like the moment you write down x plus 2 all squared equals x squared plus 4, you should feel weird. Your hand should start trembling. Like something should be, oh, whoa. You know, kind of like when you're speaking and you say something with very bad grammar, and you're like, oh, that sounded weird. And you probably don't even know what grammar rule you're breaking specifically, but you just know that something's wrong in the way you said things. That's how you want the math to be. You want to get to a point where writing down the incorrect thing just feels off, right? That's the level you want to get to. And it comes down to really focusing on what are the individual mistakes that I can make, really focus on not making those and very carefully not making them, moving on. And your brain will eventually just spot them and it'll eventually catch on. So that was incorrect. So what we should have done was x squared plus 2xh. So this is one of those things. Should I leave this here? Because I don't want you guys to forget what I'm saying. I'll mark it up later. So what we should have done was first write down this is x squared plus 2xh plus h squared, right? And again, we're working on this huge problem. I don't want to have to, in the middle of it, write down x plus h and be expanding. It's too much work, right? So I should just look at that and know that this is what it's going to expand towards. Okay. Common error writing x squared minus h squared here. Now, I'll often be doing this. It's not going to be as bad when we're moving on in the semester, but I'll often try to mark up when I'm going through an example, tell you what the common mistakes and pitfalls are. Hopefully that's helpful. And I'll try to do it in a different color so you can follow. What's in white on your screen is what you should be writing down. I'll make statements about what you should be looking out for in color. So if there's a common mistake or omission, I'll put it down in red. If there's something I want you to remember how to think about it, I'll put it in blue or maybe green. So you can actually, the notes will be sort of color coded in this way. And again, forgetting the parentheses is another common mistake. So I'll put that again here, parentheses. So we do have to remember to distribute that negative sign. So this becomes 2 minus x minus h minus x squared minus 2xh minus h squared minus 2 plus x squared all over h. Whew, so that's where we are. Pretty soon, I'd expect you to be able to get here correctly relatively quickly, okay? So if you can't do a problem like this, a difference quotient problem, relatively quickly, it means your algebra isn't really up to snuff and you really need to make sure to get that under control. Moving on. So what I can do now is, you see this h right here? I can cancel with that one, right? No, Anya shaked her head. Why is that wrong?
On your list of blasphemies.
It's on the list. Don't cancel across sums, right? There are a whole bunch of pluses and minuses on top. Do not cancel when you're in that situation. You can only cancel across multiplication. So now canceling across an h is not what we're going to do. What should we do? What do you think?
I would simplify the top row and just cancel out what you can. Like there's a lot of
Right.
like
Simplify.
the negative x with the positive x.
So we have a 2 and a negative 2. So that dies. The negative x kills the positive x. The negative x squared kills the positive x squared. Right? And this is also pretty nice. A nice thing about knowing the do nots is that whenever you're in a situation and you know what not to do, then you start looking at, well, what could I do, right? You kind of stumble into the right thing to do. Like, so if you know that I'm not allowed to cancel the h, then you start to look, well, what else could I do? You'll start to see, oh yeah, there's a +2 and a -2. You'll start to notice other things and you'll start, oh, I'm definitely allowed to do that. And so that definitely brings you in the right direction. So now we would have -h minus 2xh minus h squared all over h. H is in everyone, so I can cancel the h's now, yeah? No, shake your head. I should be seeing everyone going on camera. No, not allowed, because that's canceling across sums. Okay, I'm not allowed to cancel the h. What am I allowed to do?
You can factor out the h on the top.
I can factor out a common h. What's left over?
-1, -2x, and -h.
Now there is a multiplication. Now we're allowed to cancel. And that's your final answer. So this is I like this example because one, we're going to be doing it all the time. This is actually a very important expression for us to be able to calculate, and I'm going to tell you why that is the case. It's a very important expression in calculus. That expression is like responsible for half of calculus, no lie. So very important expression. It's also a good problem to test your algebra skills. I mean, if you could get through this relatively quickly, unscathed, get everything correct, your algebra skills are probably good enough for this class. If you made one or more mistakes on the way here, or you would have gotten this wrong, then it means you have some work to do this week. So this is a problem that I would expect everyone to know how to do day one without me actually teaching you how to do it. I get it. You know, it's been a long break. 2020 was a crazy year. You might have forgotten a lot of things, but in calculus, you would be expected to be able to do something like this, like day 1, hour 0. So I would definitely go and practice this, especially if you stumbled on this. So if you forgot, what does f of x plus h mean again? That's called a composite function. Go look that up in your pre-calc book, and practice a few problems. Make up your own functions, some other polynomials, and try to go through this. 7 minus 2x plus x squared. Try that one. Or 2 plus square root of x. Try that one. Or what if it was 1 over, f of x was 1 over x squared? Try that one, right? Try to get through some of those. Maybe you guys can tell me what you get on Thursday. Try the above for, say, square root of x, or f of x equals 1 over x squared, or f of x equals 2 plus x minus 3x squared, or something like that. Just try a few, see, could you get to them correctly? But kind of tell you where you are. So try to do that, and it'll reveal a lot to you. So sometimes you just want to get in and do a bunch of problems, get a bunch of things wrong, and then learn from your mistakes. It's an uncomfortable process, but that's how you're going to do better. So a lot of students, they're doing math, they get a lot of things wrong all the time. It discourages them from trying because I'm just going to get it wrong again. Don't do that. It's a part of the learning process. Get things wrong as often as possible before the test, right? So you want to get things wrong, want to make all your silly mistakes, so when the test or the quiz comes around, you're good. And I spent a longer time elaborating. We're almost out of time, and we're probably going to go over it by a few minutes, so apologies there. But I definitely want to get over this. I actually planned on doing more today, but I guess I won't. We'll just finish going through the syllabus. But those are some things to kind of prime you, and we're going to continue. So I'll kind of rush through the rest of this because we don't really have any more directly math stuff that I'm going to talk about. I just want to describe to you how the rest of the class is going to work. Okay, move this up. Oh, by the way, I will be creating a PDF of the notes for every class, and I will upload those along with the video for the class. Okay. But as you guys can see, while I'm writing down, I'm explaining a lot of things. So it's still worth your time to show up to class, ask questions, and see. Because I might say something and erase something every now and then. Oftentimes I won't. I'll leave everything that I'm thinking on the paper, but sometimes you never know. Yeah. So those are these guys. Very important. One, two. Go for those guys. Okay, let's rush through the rest of this. Contact. When necessary, I'll be contacting you. It can come from several places. More than likely, I'll contact you through my email, which is jsmith306@fordham.edu, or it'll come from something like Jupyter Ed, which is where your grades are going to be kept. So make sure you can do that. And by the way, I should ask, did everyone actually get an email from Jupyter? So, okay, so some people, I don't know. Maybe put a thumbs up in the in Zoom. Do you guys know how to do that? I think if you go down to reactions, you can put it like a thumbs up, or you can click the yes button that's on the participants window. Okay, so one person got it. Maybe the rest of you just didn't check. You should check. So let me actually write that down. Check if you got emails. It's very important that we keep the line of communication open from Blackboard. I'm not going to use Blackboard very often, but just because it's an online class, I wanted to use all the avenues to kind of get the word out. You should have gotten an email from me at some point, jsmith306. You should have also gotten something from Jupyter. You should have also gotten something from Gradescope. So I sent out these emails earlier this morning. If you did not get emails from these 4 sources, you should probably let me know, because it means the lines of communication is broken somewhere. So after class, definitely check. But that's going to be very important, communication. So a lot of students struggle with online classes, and I get it. Some people like being in person, and it's just kind of weird. On top of that, even students who are introverts and don't mind being alone still sometimes struggle with online classes. The trick to being performing well in an online class, it doesn't have to be harder or more confusing than a regular class, but the trick is to actually go over and above to participate. That's pretty much it. So don't be afraid to say something or type something in the chat. Just try to engage with me as much as possible, and you'll actually learn just as good or better than if you were in person. So if you're normally someone who's kind of shy and you don't really want to say anything in class, use the chat. Otherwise, really try to say things. So don't expect you guys to know everything. You're going to say the wrong thing sometimes, and that's fine. It's better that I know that you have the wrong idea so I can correct you before it really matters. So participation. So contact is very important. Make sure you can get communications from me and you can get me communications to me. Feedback, highly encourage your feedback. If there's anything you think I can do to make the teaching experience a little bit better, I'm very open to hear it. You're not going to be penalized for doing this. So if you like how I'm doing it, you can say so. If you think something else could be better, also say that. Just be constructive, okay? So don't just email me like, your teaching sucks. Be like, your teaching sucks because, it'd be better if you do this. Okay. Help. Everyone needs help from time to time, lots of places. I'm your first source of help, so you can see me during office hours. Email me for an appointment. Moving down. As I mentioned on our website, I'll be uploading all sorts of practice material, so you can do that. Tutoring I know the math department offered online tutoring last semester, so did the dean's office. I don't know the particulars this semester yet. If any of you find out before me, you can let me know and I'll tell the rest of the class. But as soon as I find out the particulars about tutoring outside of me, I will let you guys know. Also, a lot of very helpful websites that I definitely encourage you using as long as you're not in a test. So just to get used to stuff, Wolfram Alpha and Symbolab, love these two. I personally use these all the time. Very good, but the others are great as well. Don't forget your classmates. I'd recommend that you kind of exchange contact information. And at some point later in the semester, I will also facilitate this to make sure that you guys get into 2 or 3 groups in the class where you have your own little study group. If you have a disability, which entitles you to accommodations, be sure to reach out to the Office of Disability Services this week. That's the website. You can find information there. I guess that's not true anymore. Pay attention, still true. Don't use your cell phone, still true. But you can eat, I guess. It's your house. You can do whatever you want. Academic integrity, don't cheat. It's online, and there are some things where I use the honor code for, and a lot of students took advantage of that last semester. They still got caught. Don't cheat. I'm trusting you. You trust me. If you do everything as I'm mentioning and you follow my advice, there'll be no need. So just don't do it. Here are the topics, as well as suggested textbook problems from the physical textbook or the e-text. You're not required to do these or submit them. These are just for extra practice. If you feel you need to, I would say you should do those. But these are the topics we're going to cover. As I mentioned, we're going to have 2 tests. You can see the locations of the tests right here. So test 1 is going to be on March 18th. Test 2 is going to be on May 3rd. So you know ahead of time when these tests are. And the tests are not cumulative. So test 1 is going to cover this stuff. Test 2 is going to cover this stuff. And overlaps are just whatever's in common between the two. algebra will connect both parts, obviously, but I'm not going to specifically test you on these. So they're not cumulative, but of course, techniques that I teach you in the first half of the class will apply to some parts of the second half. So those are the class. Final exam, I don't yet know the dates, but I'll let you know as soon as that is up. Pre-2020, Fordham always had the final exam schedule like by first day of class. That's no longer true. So they'll update the final exam schedule at some point, hopefully soon. The quiz schedule is also here. And hopefully this is, I missed this, I have to put this in. Hopefully this is okay. We'll fill in. But I'm giving you your quizzes on Sunday mornings, just to kind of give us all some distance from class. I think that would work well. A few of the classes I was taking last semester did this, and I think it was nice. So as long as you guys are okay with Sundays, I think that's a good day to do the quiz. So your first quiz as planned is Sunday the 7th. Your first homework is due, which is homework 0, is due on February 6th. At the moment, if you're not sure if you're going to stick around for the class, you can get a trial period, so you don't have to pay up front right now. So just get access to the homework as soon as possible, and try to get through that. Doing the practice quiz on the website as well as the homework should prepare you for quiz 1. I have to put the date here. I think that's like 2 weeks prior to me too. I don't know. Here are a few important events. I highly recommend that you actually check out the full academic calendar, but as a short list, here are some important events that are going to happen, including, I don't know when our specific final is going to be, but we do know when final exam week is, so don't make any travel plans for there. We also know that midterms are going to happen around here. So you know when my midterm is going to be, but you might not know for your other classes, but you should expect it to be around there. Last day to designate pass-fail is March 12th. Last day of classes is May 5th. This also tells you when the university is closed. We started late, so we're not going to have a full spring break. I think in the middle of the semester, we just have like 1 day off or something, and that's on like March 10th or something. There's Good Friday, last day to withdraw. Hopefully no one does that. Hopefully everything goes well. It really shouldn't be a hard class. This Calc 1 class should be easier than the other Calc 1. So it'll be easy to stay on top of things if you follow my advice and you don't slack off. Really, there's no reason. And that's basically it. Didn't get as much done as I thought I would. I better rush with my other class because they have a 50-minute session. But I'll want to cover this. So next time, I will be going through these two here so you can read ahead. And that is going to be material that's on your quiz. So doing the homework and reading ahead would be beneficial. But that's kind of the schedule. And that's pretty much it. So before we wrap up, we're already over time. Do apologize. I won't make a habit of it. But there were some things I want to explain slowly to make sure that we're all on the same page and to illustrate some points. But in the meantime, are there any questions before we sign off? General questions, concerns, comments?
What did you ask us to review again in preparation for next week? The two, which numbers for the lectures?
So on the quiz, it tells you the topics. So here you see quiz 1 says topics 1 through 5, right? Which means in this list, you are going to do topics 1 through 5. That's quiz 1.
Awesome, thank you.
So I'm not going to go through the first 3 sections. That's just expected that you should know that. So things like you should know the equation of a line is y equals mx plus b, things like that. There are a lot of things that I used to teach in Calc 1, but I actually got a lot of students complain that we know this already. Why do you spend so much time teaching it? So I said, okay, fine, I'll start here then. And yeah, so So make sure you know about functions, make sure you know about combining and simplifying, make sure you know about equations of lines, slopes, rate of change, make sure you know about laws of exponentials and logarithms. I'll talk about that with you guys on Thursday. And that should put you in good shape for quiz 1. And in general, all the quizzes, I tell you what topics you're responsible for. So quiz 1 is topics 1 through 5. Quiz 2 is topics 6 through 8. Quiz 3 is topics 9 through 13. Quiz 4 is, you get the idea. And the topic number is the number in this list. Okay. So you know when all your tests and quizzes are going to happen. You know what they're going to cover ahead of time. So that hopefully will help you get prepared. Right now, I only have 1 homework posted. That's homework 0. I'll try to post a lot of the homework ahead of time as well. So you can go ahead, but try to, at the very least, keep up with the class. So when I post all the homeworks for quiz that cover topics up to test 1, I'll make them due like the week before test 1, but I do not recommend slacking off on the homework until the week before test 1 and trying to do all of them. I really recommend that you do the homework as we're moving on. But once I put in the other homework dates, this is the only one that's due early because I really want to make sure that you start off strong. But all the other homeworks, I'm going to make the homeworks for topics up to 13 due just before midterms, and the homeworks for topics 14 through 24 will be due like the last week of class. But try to keep up with the class with homeworks. Hopefully that answered your question and a lot more. Any other questions? Comments, concerns? Yeah, so I really think this class can be good. I don't tend to have a lot of issues in 1203. Most students happen to do well. And surprisingly, the few students who don't do as well are the ones who took calculus before and think they know everything. Don't do that. Really take everything seriously and show up to class, participate, really just talk. You don't have to raise your hand, just chime in. I've never been in a math class or a situation where it's like 10 people try to shout out the answer at once. It's never happened, right? Like chances are, if you want to say something, you're probably the 1 or 2 people who are going to say it. So just chime in or type in the chat, but do engage. Do not just sit there and just stare at me. Take notes, engage, ask questions. That's how to get this online class working for you. You're going to have to work extra hard on staying engaged. If you don't, you're not going to do as well, and you're going to think that it's the online class that is the problem, but it's not. It's just that you're not having the level of engagement that an online class requires. It's really okay. Someone sent me a message that they have to go. It's okay. We're over time. I'll post the recording and you'll be fine. But yeah, definitely do try to come out of your shell and engage as much as possible, and you should be fine. Any other questions, concerns? Okay, so I will post the video with these notes, and just remember to go through them and check that you got all these emails. And if any other questions come up, just shoot me an email, ask me a question. And just look out for the forum to be up. I think asking questions on a public forum are better. So I want you to save, in general, I want you to save emails for personal questions, right? So if you have a scheduling conflict or something like that, that's a personal question. But if you have a math question, I'd rather you ask the math question kind of publicly. And I'll try to do it in a way where it's anonymous as well, but really it shouldn't be a problem either way. So that once I answer you, everyone benefits. And I think that will work out nice. So I'll update you on that. That being said, good morning. Welcome to spring 2021. Hopefully you're all doing okay and will continue to do so. Yeah, so I'm going to sign off unless there are any questions. Bless you, Caroline. Okay, so we're good. Kakashi. Okay, yeah. Okay, so at least someone got it. Okay, all right. We'll sign off. I will see you guys on Thursday. All right. So yeah, that's it. So see you in the next one. Ciao.